Right. I just thought it was quite useful to put this map up to give you a little bit of a sense of where we are. Our core area is shown that we're going to be talking about today, but you'll find it drifts around a little bit because it's a landscape. And so the key thing here is that the pink on the map is the southern magnesian limestone area, which hopefully we can convince you is a really important landscape. However, it sort of falls outside the protected landscape. So on the west side, you've got, actually it doesn't show terribly well, the, oh no, I can just see it, the edge of the Nidderdale area of outstanding beauty, now known as the National Landscape. So this is the Nidderdale National Landscape. And the area out here is the Yorkshire Dales, and the area off to the right, up here, is the edge of the North Yorkshire Moors. So we fall right outside it. And just a point of interest, the darker green areas are SSSIs, of which there are, there is, for instance, Ripon Parks and other little tiny bits within this landscape. But it's a landscape I've been fortunate enough to live in for the last 40 or over 40 years, or my wife would tick me off now for saying we have lived in the last 40 years, and I've got a great affection for, and I think it's an incredibly special landscape. And living just on the edge of the southern magnesian limestone, hopefully I can show you a little bit about the wildlife of that area later on. Crucially though, being a landscape, we need to understand the history. As to summarise Churchill very badly, if we don't understand our past, we can't possibly understand our future, or we can certainly better understand where we can go in the future. So it's a real thrill to me to have the team of speakers that we've got today, who will take you back to at least the last ice age, with hints of what happened before the last ice age as well. And then come through the history, the medieval, through to early modern. And at the moment we don't have Arved yet, and hopefully he'll be here fairly soon. I think he's got children's drop-off. But he'll be talking about recent river movement where it's followed dolines, I now know they're called, where gypsum collapses. So it's a really interesting and dynamic landscape. So at this point in time, I will hand over to David Hill, Professor David Hill, who will very kindly chair the morning. So welcome.
Thank you. Well, Simon, last night I had the great fortune to have dinner with Jill and Simon with Mary Colwell, and Simon said, "Well, he said I chose you to chair the morning session because you know a lot about the past rather than the future or what's likely to happen in the future." I've known Simon now for a number of years, and I think it's spectacular what he and his wife Jill have been achieving at the Nosterfield part of this project that I know most about, being one of the nerdy birders with the telescopes and looking at birds and seeing Emma doing all the hard work in the place. And so it's a great privilege really to be able to share this first session on subjects which I'm really interested in but know nothing about. So all of this geological work, etc., that we're going to hear about this morning. I think that, as Simon said, you've really got to know about the past if you're going to plan management for the future. And I think that conservation tends to forget that in many instances. And we see an example here of a local, the Lower Yore Conservation Trust, being able to deliver something of spectacular value for local communities, but also for regional and national importance. And the Nosterfield site itself is becoming, I think, nationally important now for a whole group of bird species, for example. So, in my mind, it's the introduction of the academic understanding of how landscapes work, how soils work and how that then creates the habitats on which various species thrive and makes these wonderful places that we all like to visit. So I'm going to introduce our first, we're slightly ahead of time I think, but I'm going to introduce our first speakers for this morning's session. I think David and Jim are working in a dual act, I think, on this, as I understand it. And if there's time at the end for a couple of questions, we'll do that. But we do have a sum up and questions time at 12:30 before lunch. So without further ado, as they say, can I introduce Professor David Bridgeland and Dr Jim Innes from Durham University, and they're going to talk on the River Ure prehistory. Thank you, David.
Good morning, everyone. I'm David Bridgeland. I'm not two people. I'm going to hand over to Jim halfway through. And you'll see that, I don't have my pointer. Where's my mover honour?
Just behind you. Is that okay?
Thank you very much. I haven't been instructed in how to use it either. Let's just try it. Yeah, so you'll see that the speaker that follows us is part of this presentation as well, because this is a presentation based on a project we did quite a long time ago now. And all the different partners in this project are on here. Really, we had a lot of help from the Conservation Trust in this project. It all begins, as far as this part of the world is concerned, with the last glaciation. Now, as a man of Kent, I can go further back in time than that. So that's an unusual situation for me. But I've been working in Durham University within the footprints of this last glaciation, which you can see on this map in the corner, nearly as long as Simon's been living on the Magnesian limestone. And to me, this is the big destroyer. I had a lot of colleagues at Durham who love to study glaciation and its deposits and what it's done to the landscape, but it wipes everything clean, apart from the bedrock. So everything that happened in recent time before this glaciation has gone from this part of the world. So it's a starting point, and our little project area is depicted there, and this is what it looks like. And if I move the slide on, you can see a very similar oval to the one Simon had, I think, which is not our entire project area, but it's where we home in on the lower Ure, which is what we've been asked to speak about today. And the sites are listed there, and this is the mapping that was part of the project that was done by this gentleman who's not here. That's Wishart Mitchell, Dr Wishart Mitchell, who spends his time in Scotland now, which is his home country. He plodded across this entire landscape, mapping all the geomorphological features and taking note of the material under the ground if he could see what it was. And that formed the basis of our project. And you can see some detailed maps, which I can't see terribly well. Okay. So there's that glaciation in a slightly more modern, trendy form, using what we call a DEM with all the landscape features, although the glaciations tend to obliterate. And one of the main changes is that we now think the last glaciation went all the way down to the Isles of Scilly, which is a minor detail that's got nothing to do with the lower Ure, but I thought I'd just point it out. What it left in our landscape are ridges called moraines, which were the ends of the ice sheet at points in its retreat. Most of the evidence for what it did is really showing you what it did as it disappeared, because as it moved forward, it obliterated everything. I said it was the big destroyer. But as it retreated backwards, it left a series of these ridges called moraines. And you can see some of them are marking lobes of ice that were coming out of Wensleydale. Wensleydale had its own glaciation, nourished in the higher Pennines at the head of Wensleydale. And that came down and coalesced during the major part of the glaciation with ice that was running down the Vale of York. And so you've got some of these moraines marking retreat phases of ice in the Vale of York, and some of them marking where the Wensleydale ice pushed outwards. And actually the Wensleydale ice pushed outwards onto the Vale of York after the main ice had disappeared and moved backwards. Or that's not what I should say. It didn't move backwards, it retreated backwards, which meant it melted backwards. And that left us with some of our most prominent features, one of which, the A1 follows for quite a distance south of Catterick. When you're on the A1 driving southwards or northwards and you can see lower ground on either side of you, you're on the Leeming Moraine, which was one of the features left by the Wensleydale ice. That's our project described there, the Swale Ure Washlands project. It was funded by the Aggregates Levy Sustainability Fund, which was it was Gordon Brown actually who brought in the aggregates levy, and it was designed to make recycling of aggregates economically viable. The money obtained from the levy was put into a number of good causes, one of which was to fund university folk like us and other allied people to do projects like this, which were designed to mitigate the effects of quarrying for aggregate. And there are some of the effects of quarrying for aggregate. This is the Nosterfield quarries, which form a large basis for this meeting, I think. And you can see the 3 Nosterfield or Thornborough henges there and how close they are to the quarrying, meaning that archaeology is part of the story here, as well as the environmental changes that have occurred post-glaciation. So, straight to our results. In a nutshell, we did 3 or 4 years, no, 3 years I suppose it was, of research in this area, and we came up with a sequence of post-glacial landscape change, environmental change, that can be summarised in what I'd call a staircase diagram, because this is a terraced landscape. I don't know if you have heard of the term river terraces, but rivers tend to leave terraces behind when they're cutting their valleys down into the landscape, which they do usually in response to uplift or lowering sea level. And there's a debate that's been going on for decades about which is the more important. As in most controversies, there's probably an element of truth in both. Here, it might well be isostatic uplift as a result of the unweighting. Is there such a word? When the ice melted, the land was buoyed back up because that weight was removed. And that uplift might be what caused the rivers to erode into the landscape. So what you're seeing here is stages in what's happened since the ice melted with the river. Well, there's the river there, the River Ure. It's sitting over the top, though, of a considerable thickness of post-glacial sediment, its own sediment. And this is a pre-glacial version of the River Ure Valley. So there was an earlier River Ure Valley, and the modern river doesn't flow over it everywhere, but it flows over it in quite a lot of places. So this is diagrammatic. Some of the time the modern river is flowing over the top of this. As depicted here, it's shown that it's wandered off it. And that's the story for all the rivers in northern England within the footprint of that glaciation. They sometimes flow above their old valleys, which are filled with glacial sediments in the main, because the glaciation brought loads of sediment and left it there, plugging all those valleys, and sometimes they've cut new valleys elsewhere, the Durham Meander being a classic example of that, and sometimes they sit above and cut into the deposits that fill their old valleys. And that's one of the key things we need to work out. So this story starts at the top, because the oldest is the highest. The river's been cutting down, remember, so the oldest and the highest above the river is at the top, and it's a staircase. And we'll start at the top of it. Now I've got a black and white version of that summary diagram, and this is the beginning of the story, Marfield Quarry. Marfield Quarry near Masham. Masham? No, Masham, isn't it? I'm not a Yorkshireman. I've already said that. Exposures there showed that the ice was still around when the deposits that are being quarried at Marfield were in place, because there's boulder clay or glacial till, diamicton, it's called these days, interbedded with gravel, and the gravel is outwash. It's meltwater gravel from that ice, but the Ure has emerged already from the glaciation because the ice has pretty much retreated to this point. The ice front is at Masham when this set of deposits were in place. And it's about 30 metres above the modern river level. And that's the same height as Newcastle sits above the River Tyne, and Darlington sits, the River Tees at Darlington sits below a glacial terrace in the Tees. So that's a common story right across the northeast of England. there has been about 30 metres of incision of valleys, cutting down of valleys since the ice melted. So these are, and that's our colleague Dave Roberts, who contributed to this project, but we forgot to put his name on the book, and he will never let us forget that. From Marfield Quarry, there was the meltwater cut this gorge, or at least flowed along this gorge, the Hackfall Gorge. We don't really know whether that gorge was there from a previous glacial cycle or whether it was freshly cut. I've never actually set foot in it to see, but the chances are with a narrow gorge it will have been flushed clean of any sediment that was there before. So I wouldn't expect to find any evidence for whether it's been previously occupied. And from that Hackfall Gorge, the water fanned out at the end of the limestone outcrop to form the Nosterfield Fan. And this is the fan on which the Nosterfield quarries are to be found. And you can see sediments. Again, they're outwash sediments. The water has come from the ice front down the gorge and then spread out in this fan. And so there's a big area of gravel, again, just right for quarrying. And already we're a much lower height, about half the height down to river level has been achieved. So this is only about 15 metres above river level at the Nosterfield Fan. And that's a picture you've seen before. So these quarries at Nosterfield, these henges at Nosterfield are on the Nosterfield Outwash Fan, which has a number of holes in it, for want of a better word, filled with organic sediment, and that's what Jim's going to talk about in the second half, as well as organic sediments elsewhere. So these provide an excellent record of post-glacial environment. Some of these go right back to almost to the melting of the ice. The next thing in the staircase, let's go back to the staircase. No, it's a long way back to the staircase, I won't bother. Oh no, there it is. Yeah, the next thing in the staircase is the Marfield Channel. And that is the Marfield Channel. Or in fact, you can't see it yet because I haven't moved the slide on. That is the Marfield Channel. See, helpful, that dashed yellow line is quite helpful, because you didn't really notice that was a channel until I showed it with the yellow line, did you? There is quite a marked channel right next door to the Marfield Quarry, and you can see from the staircase how much lower it is. You see that channel, the surface of the channel belies the fact that it's actually cut much deeper into the landscape and filled with sediments, which again mark the early period following the end of the glaciation. So that's the next phase in our story. We call it late glacial. That's the first few thousand years following the melting of the ice. There was an initial warming, which we call the late glacial interstadial, and it got cold again. And then the present interglacial, which we call the Holocene, that began in earnest, and we never look back, and we're making sure it never ends. And so Ripon, yes, I think Fountains Abbey is on this. I didn't notice this last night. Isn't this Fountains Abbey over here? Yeah? Those are some of our sites at Ripon, and I took the slide out that mentioned the gypsum solution, or the gypsum collapse, the cast from the gypsum, because I saw that someone was going to talk about that this afternoon, which will be very interesting. But we had a site at Ripon Racecourse, a gravel quarry at Ripon Racecourse, and we have a channel site at Sharrow that we've studied, and this continues the story, and some of Wish Mitchell's mapping of the Ripon area and the Nosterfield. Can't really see that from here. Yeah. So, two key sites at Ripon, the Sharrow Channel and Ripon Racecourse, or Ripon South, as we renamed it. That's that Ripon South quarry. Brown and Potters operated it when we were doing our project. That quarry was studied earlier at the very end of the last century by Andy Howard, who was, I think, working at Leeds University at the time. And he studied a terrace here and did some terrace mapping. So there's a little staircase of more recent terraces down nearer the river that are beautifully depicted and understood in the immediate Ripon area. And the Sharrow Channel is part of this story, although it's a channel fill and not a terrace. And so this is the mapping of these terraces by Andy Howard, and mapped onto the Ripon Racecourse Quarry. So you can see the racecourse there, and the quarry, when we studied it, was here. When Andy Howard studied it, was over here. And so he was in a higher terrace than us. He was in terrace 2, because he was the one who was responsible for numbering the terraces downwards. I would always number them upwards. It's bad geological practice, because you should number things from the old to the new. But with river terraces, because the ones nearest the river are the best preserved, being the most recent, we tend to number them upwards, and that's the geological survey method. But Andy Howard did it the other way. He wouldn't mind me saying that, because he's a mate of mine. But that's, again, one of the controversies that we have in the field. So, yeah, this is the Sharrow Channel. Have I got a yellow line that's going to show it? Yes, so the Sharrow Channel. We studied it at a site up the far end. We can see where the study was, because there's an arrow there, using a mechanical corer with an A-frame on the day we won the Ashes in 2005, so we'll never forget when we did that. And that's our other site at Ripon, which is off to the north of the map that we showed previously, Ripon North Quarry, which are quarries here that straddle the river, in fact, and they sit above the glacial channel, so there are glacial deposits immediately beneath the terrace deposits, a big gap between the glacial deposits, which date back to the end of the glaciation over 10,000 years ago, and the much more recent terrace deposits on top. And that's the section in the Ripon South Racecourse Quarry. These muddy deposits in the background are much more recent even than the main terrace deposits there. They represent a medieval channel fill, probably an oxbow lake, where the river has abandoned a section of its channel, and it got filled in by floodwater getting into it probably over quite a long period. And we know that this is medieval because we've done some radiocarbon dates on it, and we found these medieval cobbler's waste. A cobbler was making shoes and chucked the waste into the river, presumably, and that's so we get these are the soles and some bits of the uppers of a sort of elf-like shoe from medieval times. We got some advice on that from archaeologists, of course. And that's some wood from that quarry. And there's this shell that is an indicator of the late Holocene that we found in the gravel. Some of the gravels and sands were very shelly in this quarry. So, what have we got here? We've got the Marfield Channel. Oh, this is Jim's first slide. This is your first slide, Jim.
It is, yes.
And I finished in a quarter of an hour. Look at that.
Very good. I thought you were going to do the lot there, Dave. I thought you were going to do the lot.
No, you carry on. I don't know, what am I going to say about this slide? And then I realised it's not even my slide. What a slick segue that was. There you go.
No one would have noticed, really, would they? To work out how to use this. There we go. Right. Well, good morning, everyone. David has talked about the glacial heritage in terms of sediments and in terms of landforms that we have in the lower Ure area. And that's tremendously important because it sets the scene for the development of all kinds of other things in the 14,000 years since the ice retreated. And very important among those are the biological changes that have taken place. So we're looking at changes in vegetation, we're looking at changes in the fauna as well as the flora. And we're also, and increasingly as the post-glacial goes on, we're looking at the impact of humans on changing those biological systems. Now, for the first half of the post-glacial, they were really determined by natural environmental changes. So changes in climate and all the things that spin off from that in terms of rainfall. But in the second half of the Holocene, of the post-glacial, we're looking increasingly upon human impact on those systems and how they're being changed in order to be more and more useful for human activities and for human settlement. So this first slide goes back to the Marfield Channel that David was talking about. And this is the high-level channel near the Marfield Quarry. And this is actually the Marfield Channel itself, You've seen an aerial view of it. This is from standing on the side. And you can see here that it's up here. And there are similar channels as we move down the system. David's talked about the Sharrow Channel and the Nosterfield Fan, which contains many channels and depressions within it, caused by various landform activity. And there are channels here that we think are occupied these days by the present rivers, Laver and Skeller, come together at Ripon. So these channels are everywhere in the landscape. And I'm only going to talk about 2 or 3 of the most important ones today. And if we start with Marfield, you can see that it's a wetland. There are wetland vegetation growing in it. And if we go to a channel like this, it's been accumulating sediments since it was formed. So it should have a legacy of several thousand years of sediment accumulation. Now, these sediments, we have different sorts. The glacial sediments that David talked about are mainly clastic. That means they're mineral-based, and they're not organic. But the sediments that accumulate in channels like this will be of both sorts, both of inorganic and also organic, depending upon the depositional systems that were operative at any time in the past. Later on, we're going to have a look at the Nosterfield Fan and look at some depressions in the fan and what they contain. But if we move onwards, we can see here that we're looking at the kind of site from which you get these sediments, which you can then interrogate by various kind of archaeological science techniques. So here we have what is basically a hole in the ground, surrounded by higher land, and you can see it's got wetland vegetation on the top, and these are called kettle holes, and this is actually from Wensleydale. And this kettle hole would have been formed when a block of ice was left behind as the glacier retreated, and these blocks of ice stayed in depressions in the landscape, and then they gradually melted. And when they melted, they left a hole behind. And the hole can be 10, 15 meters deep, maybe, or maybe not that big, depends on how big the block of ice was. But it will have been accumulating sediments over thousands of years. So this is a typical kettle hole that you would look for a long period of sediment accumulation, which is very valuable for reconstructing past environments. How do we analyze the sediments that are trapped within these depressions? Well, this is at Sharrow, and this is the rig that we used to get the sediments from Sharrow. We used that because the upper sediments were very firm, and we couldn't really get through them with a hand corer. So we spent a fair bit of money getting these people to retrieve a column of sediments for us from Sharrow. Normally, if you can, if it's entirely organic, people would use a hand corer. That's me, and that's our colleague Mairead Rutherford that we'll bump into later on. And if you put a section through one of these kettle holes, and thanks to Mike Griffiths Associates for this picture, this is only a couple of meters deep, but you can see it contains a sequence of organic sediments resting upon the glacial sediments beneath. A couple of meters here, but it could be 6, 7, 8, 9, 10 meters worth, which you can retrieve using a hand corer, as in the example there. And these are the kind of sediments we get out. You can see they're very different. At Marfield, almost all of the sediments were inorganic, probably because of its proximity towards the ice front when this was created, and it was created in the late glacial period, and many late glacial sediments are inorganic. This is a kind of marl, this is more of a clay. If we go to other places, like on the Nosterfield Fan, you can see we have sediments which are highly organic, they're virtually peats, and they're resting upon marl sediments. So when you get a change from that kind of sediment to a different sort of sediment, or here, for example, from a lake deposit into a peat, they reflect changes in depositional environments. So changes in the sediments are a very good way of finding out how the environment changed from time to time. And on the Nosterfield Fan itself, there's one of the henges. This is an aerial view taken by our colleague Wishart Mitchell, who seems to have done most of the work on our project, to be honest. You can see all of these here are channels and depressions running through the gravel and sand of the Nosterfield Fan. And any of these depressions will have accumulated sediments over time. So we've got a lot to look at. We could have done very many of them, but we chose really to look at the more interesting ones nearer to the Thornborough Henges. So those sediments we saw in the previous slide, they represent changes in depositional environments. And if you go to a deep sediment sequence, you're likely to get a change from open water through reed swamp into a kind of swamp car environment, where it's getting more and more terrestrial and the water's getting more and more shallow. You move into a kind of wet woodland, very boggy, but with trees growing upon it. And then eventually you move into an acid bog. And that's on the way to becoming a raised bog like you get in the Pennines and elsewhere. And all of these different depositional environments, which are successional through time, and one leads into another, they will all collect information regarding the vegetation and the sediments that were laid down as time went by. And it doesn't have to be a linear temporal thing. You can have a lot of very similar environments, wetland environments, because they are the environments that collect these sediments. You can have open water, you can have alder carr, you can have various kinds of fen and reed swamp environments in very, very close spatial proximity to each other. So when you're collecting sediments in there, you're getting all sorts from all these different environments that are near that area, from the catchment of that little lake. What do we do? Well, one of the best ways is to look at the fossil pollen that has been collected and preserved within these sediments. Pollen's released from plants all the time. People with hay fever will know very well about that. I have that. It's not very nice. And different plants produce different amounts of pollen. So, for example, pine produces tens and tens of thousands of pollen grains from a single plant. If you go into the mid-Atlantic and you take samples from an airplane, the air is full of pine pollen. It gets everywhere. Herbs, however, produce a far less pollen because the pollen is it's insects that transfer pollen from one plant to another, whereas with things like pine, it's the wind that does it, so it needs to produce a lot more pollen. That means you have to take that into account. It's not a straightforward relationship. But these are the different pollen grains of many of the main trees, and you can see they're all very different. So they're all diagnostic. So it's easy, or fairly easy, to identify the different pollen types, and from there you can go on to suggest what the environment was like, what the vegetation on the landscape was like around where this pollen's been deposited. So that's the basis of pollen analysis. And some of them are really quite pretty. They're quite nice looking, quite interesting. However, what you then do is you have to produce a pollen diagram. Now, this is a basic pollen diagram. It's actually not a real one. It's an artificial one put together just to show how it works. But basically, it's only a graph. So you've got time down the side, and I've put the archaeological periods on there just as a help. And you've got dates down the side here, radiocarbon dates in this case. And what it is, it's depth against abundance of the different sorts of pollen. And by the proportions of the different sorts of pollen, you can, A, tell what the landscape was like in terms of the vegetation, the forest, the woodland, or whatever. But also, because it changes over these last 13,000 years or so, it's a relative dating technique. So you can look, and if you've got a pollen assemblage that looks like this, and you're a practiced pollen analyst, you can say, well, this was probably between about 7,000 and about 9,000 years ago, just by the different proportions of the pollen. But it's much easier to get radiocarbon dates, although they are a bit expensive, to be honest. But this illustrates very well how, over the last 14,000 years, the vegetation has changed in northern England and throughout Britain as a whole. So in the late glacial period, which takes us up to about 10,000 years ago, in radiocarbon terms, David said that it was warm during the late glacial interstadial, and then there was a very cold phase, and then after that it got warmer in the Holocene, and that's shown very well by the birch pollen curve. Birch woodland only prefers warm conditions, and it needs a period of warm conditions to come into being. But you can see here there's not much birch here or here during the cold phases of the late glacial. There's a fair bit of birch in the warm phase, There's a lot of birch at the start of the Holocene, but then other things like hazel, and then oak and elm and alder, and all the deciduous trees that we're familiar with, the thermophilous trees that like warm conditions, they come in one after the other during the Holocene as it progresses. So that by about 7,000 years ago, you've got the full mixed oak deciduous woodland developed in the landscape, purely down to plant succession and climatic change. Then as it moves through time, you get to about 5,000 years ago, and there was a big decline in the amount of elm pollen that you see in pollen diagrams. We'll come on to that later, but it's a major feature in pollen diagrams. And we have it in the Lower Ure and the various sites we have. A big decline in lime pollen in the middle of the Bronze Age at about here. And when we get up to the Iron Age and the Roman period, you can see that a lot of weeds, and you start to get cereals, you start to get various indications of human activity in agriculture. So that's an important change. So the first half of the interglacial climatic change, natural. Second half of the Holocene, more human impact, people coming in doing agriculture.
3 minutes, Jim.
3 minutes, really? Okay. Right. Very quickly then. This is Mairead Rutherford, our pollen analyst. This is a succession of things that happen after the Ice Age until you get the establishment of that closed canopy woodland. This is a pollen diagram from Marfield. And you see, going back to that big pollen diagram with the big rise of birch, this is the beginning of the Holocene. Juniper comes in to begin with, and then here you've got the very, very cold late glacial phase with lots of weeds, lots of tundra herbs, and lots of sedges and grasses. So that's a good example of that change from the late glacial to the Holocene. And you see it again here at Nosterfield the Flasks, where we've got birch coming in, followed by hazel at the beginning of the Holocene. We've got a very cold phase here with hardly any trees at all, lots of grasses, lots of sedges, and then back into the warmer part of the late glacial, you've got, again, birch forest being developed. So climatic changes in the late glacial and the transition to the Holocene. And this illustrates it quite nicely. You move from bare ground with moss, and you move into tundra, into taller plants, juniper bushes, and then birch copses as the Holocene gets going. So the landscape of the central Pennines and the Ure can be seen in time slices. You've got the end of the Ice Age, bare rock. You've got about 12,000 years ago when you've got tundra conditions. You've got developed forest halfway through the Holocene about 6,000 years ago. And then the present day, you've got the moorland of the uplands. Environmental evidence for human impacts. These are some of the proxy indicators we get, things like charcoal, things like cereal pollen, things like Plantago lanceolata, rubwort plantain, which is a good agricultural indicator. You've got some things like these fungus spores. Sporomyella is an indicator of animal dung. So all these proxies can tell you what's happening. If you go to Snape Myers, a bit further north of here, at about 9,000 years ago, when hazel comes in and takes over from birch, you've got a lot of charcoal coming into the section. Now, is that natural burning, or is that Mesolithic people burning the birch forest and encouraging the growth of hazel? At many sites, you get hazel rising and charcoal at the same time. So that's worth thinking about as a possible human impact. Has my thing stopped working? We'll skip that. And we move on. This is the elm decline. The elm decline is very important because it's probably the first signature of Neolithic farmers having an impact on the environment. However, it could also be disease and it could also be climate. There's a fungal pathogen, the elm disease fungus, which we find at the same time. So it's probably a combination of all these things. These are the various vectors that could cause the elm decline. But the elm decline is a signature of the start of the Neolithic period. And Blaise, I'm sure, will talk about that a bit later. If we go to Hutton Moor, near another henge, which I didn't realize there was a henge at Hutton Moor until quite recently, you can see that the elm decline is well seen. This is the elm pollen curve. It stops there, and this is where cereals and weeds and things start to come in at about 5,000 years ago. Good illustration of human impact in the Neolithic. And at Newby Wisk, which is admittedly on the Swale, but never mind, we have here The elm declined at about 5,000 radiocarbon years ago, and the elm declines, and all of these indicators of agriculture start to come in, particularly a very big serial pollen curve. So on the calcareous soils around Ubuisk, Neolithic people doing a lot of farming. And these are the kind of things that Neolithic people would do, felling trees, girdling trees, and manipulating the woodland, setting their beasts loose in the woodland, which has a big impact. If we move on quickly to a site at Nosterfield at F45, there are indications down here of some impacts on the environment at the time of the Thornborough henges, but very little. It's really heavily wooded. So it looks like the Thornborough henges were emplaced within a fairly wooded landscape, not an open agricultural landscape. Move up to the Bronze Age, we get much more impact upon the landscape, much more forest clearance, and then when we get into the Iron Age and the Roman period and later, we have massive forest clearance going on and real deforestation. Neolithic to Iron Age pollen evidence. Another example here you see as a huge climatic deterioration at about 2,800 radiocarbon years ago, about 800 BC, a big switch during the Iron Age, but there's also a big increase in agricultural indicators. So again, we're seeing that there's very little in the Neolithic, there's quite a lot in the Bronze Age, and there's an awful lot in the Iron Age. And that's the impact of humans using agriculture. Finally, if we go to Sharon Myers, we can see similar things going on. Once again, a lot, I won't dwell on this, but there's a lot in the Bronze Age going on, and an awful lot more in the Iron Age with massive forest clearance. Finally, David said that Ripon South, we've got a very nice channel there that has sediments in it and has those shoes in it. And this has a medieval pollen record. So down here, I don't know if you can read it, but that's 700 radiocarbon years ago, so that's probably the 12th century or so. This is the medieval. And you can see that in medieval times, we have really massive impacts upon the local environment. Lots of cereals, lots of deforestation, lots of signs of agriculture. And the last slide is a summary of human impact on the environment in the area. Mesolithic, probably not very much, maybe the odd bit of burning. Neolithic, surprisingly little, really quite wooded in the Swale area. The later Neolithic, an increase, but still really not a lot in the Bronze Age, and then massive clearance in the Iron Age, Roman period, and then through into the medieval. And that's the environmental background to the archaeology that Blaise is going to talk about now.
To see that, and I've got my eye on a warm Holocene. That's what I want to see come back, really. As long as you've got a decent health service, I'd go for that. So yeah, just to introduce our next speaker is Dr. Blaise Vyner, consultant archaeologist, and Blaise is going to talk about the Swale Ure revisiting the past. Blaise.
Thank you. Good morning. This is an introduction, really. I have to say I broadly agree with everything that Jim said. So I could almost sit down now. What I want to do is to update you on some of the archaeology that's taken place since the Washlands volume was published. So I'm assuming you know what the Washlands volume has in it. And what I really want to do is develop on some of the themes that come out of more recent work. And when I talk about more recent work, I'm thinking about major projects and indeed some minor projects, but there are some biases in the sample that we do have. In some areas there is a lot of archaeology that's taken place, in other areas there's been very little. So looking at what we have, in the study area since 2010 there have been 280 monuments added and 378 event records, but you have to apply a microscope to some of those definitions. 280 monument records might be individual sites, there might be a place name, there might be some finds of pottery or a few flints, or indeed a single flint. So a monument is not necessarily in HER terms very helpful. And then 378 event records. What does that mean? Events are when somebody goes out into the field and digs a hole or takes a boring or a core, something like that. 378 event records may not mean that the events were at all interesting or produced any information at all. It is just that somebody went out and did something and reported back because the contract required them to report back. So you have to be very cautious when people give you straightforward, splendid, this is worth national government really. You have to be cautious about that. Right, well, themes come out of the work that's been done in the washlands. Communications, people travel or they don't travel. Settlement and agriculture, which can be variable, and ritual and ceremony, which is particularly obvious in the washlands really. So, to stick with communications, the rivers we've seen are dynamic and continue to be dynamic. So this image, for instance, of the Middle River Swale, you can see the banks are eroding, but those banks themselves were the result of Iron Age agriculture and sediment being swept down the river. The Swale at Catterick, a meandering river and a spate river to this day, and responsible for a lot of changes in the local sediments. So, are rivers useful for communication? A lot of people say they are, but I think much of the time the rivers have not been helpful, not navigable, nowhere that you really want to walk along because of the vegetation. You're also impeded by smaller channels feeding the river. So the idea that you can walk along the river bottom with any great ease is usually a mistake. So yes, and choked with vegetation as well. So this is the point I've made before now. It's not easy to think, although people do talk about people traversing the Pennines or going from east to west, which they had good reasons to do, it wasn't always easy, and not many people may have been doing it. This is one of the papers which it actually makes interesting reading, but I raise my eyebrows sometimes at some of the statements that are made, as we'll see in a minute or two. Right, among the projects immediately spring out, they do introduce themes like communications, settlements, ritual, but they also reflect biases. There have been some major projects in the region, so one thinks immediately of the A1 upgrade through the washlands, or for quarrying, for instance, where you have large-scale works. But those large-scale works are biased by the fact that they are large-scale, and the archaeologists are dealing with people or agencies which are more likely to fund archaeology than not. So when you look through for the results from work on housing estates, for instance, it's a very different picture. There's a lot of work going on, a lot of house building going on around the region, and you'd be surprised at how little archaeology is coming out of some of those housing developments. It's a question of scale, and the larger the scale, the more likely it is that you'll get results from archaeology. The smaller the scale, the less likely, partly because it's being done by different people at different budgets, at different ambitions. So, this is the Roman road at halfway along it's at Heelan Bridge, and you see, let's see if this works. Yeah, just about. There is the Roman road, there and here. But there, in that poorly lit section, or not lit at all section, there is the section of the Turnpike Road, which runs sort of there. And then the latest one is the 1920s or 1910s tarmacking of the A1 and a much wider and much more level surface there. That is a section of a very rare surviving section of the old Turnpike Road, which is the kind of road that the highwayman would have known. And that's the fastest way of getting up and down the Vale of York. We tend to forget that these days. It's particularly easy now that drivers are on strike or neglected. And this is the modern A1, which we've seen transformed in the last 30 odd years into by stealth into a motorway. So, communications. Heavily wooded, as we've heard from Jim, until possibly the early Iron Age. Jim might say earlier than that. Rivers impeded, valley bottoms wet and marshy, valley sides impeded, agriculture really from 600 BC, but it increased the sediment content of the rivers, which might have been a further impediment to travel. Drainage of the area probably developed from Romano-British times, but was accelerated in medieval times. So we moved to settlement and agriculture. I was afraid Jim was going to show you these slides, but he didn't, so I'm pleased about that. This is, one of the sites he mentioned is a kettle hole. This is Killerby Quarry, just south of Catterick. And it's a quarry site, and Kettle Hole is, as we've heard, a depression from which ice has melted, leaving, over time, leaving variable environmental conditions. And as a kettle hole, which was looked at as part of advanced work for a quarry, that produced a timber platform in it. There, but it also has a sequence of activity and occupations, which is really very interesting. We have very, very little prehistoric and indeed early prehistoric settlement evidence in the area. I mean, usually flint, sometimes pottery. Very, very unusually habitation or even activity areas. I don't think there's a Neolithic site, a Neolithic house actually known from the Washlands still. And there aren't that many from North Yorkshire as a whole. But this is a timber platform, which I'll refer to my notes here. An oak timber platform, organic peat with plant remains, carbon date of 5723 to 5671. Calibrated BC dates, not BP, so round about 5,500 years old. A platform which was on the edge of a pond or a wet area, so potentially there for wildfowling, collecting food, etc. And that's clearly Mesolithic. There is a post hole with an early Neolithic date, so moving from 5,500 to 4,700, around about 4,007 Cal BC, early Neolithic, so people are there in that time, and an upper layer with a plum stone or something like that, picnic tea, 1864 BC, so early Bronze Age. And they weren't over with it then because there is a pit with charcoal at 1500 BC. So this does not represent continuous occupation. What it is episodic activity by people who are making use of what resources present themselves. And here, those resources varied over time. But the important thing about this kettle hole at Killerby is that it's so rare. There it is, kettle hole, organic peat, post hole, fruit stone. A very interesting sequence. Right, well, settlement and agriculture. Where are they farming? In general, in very limited scales until the earlier Iron Age, and possibly not until the mid-Iron Age. Where are they living in the Neolithic? we don't really know. I mean, the example we saw in the kettle hole is obviously episodic. You don't live on the edge of a kettle hole for very long. What do we find in the Washland area and elsewhere in Britain? We find pits with pottery and bone and flint, but we don't find them everywhere. They're for various reasons. We find pits, and we assume that those pits are the best proxy evidence for settlement. So they're living in very light houses, structures, which aren't constructed with large post holes or anything like that. They're light, very light, maybe hides on light frames. But we're not seeing any significant evidence for houses. We see pits. Not that many of them. There's one from Pick Hill in the A1, and that one is from Stokesley White House Farm. You will notice that the soils there are heavy gravels, and this is the result of the post-glacial activity, glacial and post-glacial depositional activities, and those soils are extremely difficult to identify pits. So one reason we're not seeing pits is not necessarily because there aren't any pits, it's just because the archaeologists have difficulty in identifying them, and some archaeologists are better than others, it has to be said. Right. We move on to another evidence from pits. This is Stokesley again. That is late Neolithic pottery, so it's going to be around about 2,800. It's slab-built pieces. It's not wheel-turned. It's chunks of flat clay stuck together and fired in bonfires. Again, the pits that go with them. Yeah, there. Metre and a half in diameter, oval sometimes, and they contain debris which may be ritually deposited. So you may find some pieces of some pots in one, other pieces of other pots in another. So there seems to be ritual associated with it, as there was, I think, with many aspects of everyday life. So very difficult to distinguish ritual from settlement in general. Right, so early arable agriculture, very little evidence at all until the middle and later Iron Age, and even that is not present much in the washlands. Tree clearance, yes, some clearance in the Neolithic. Was the elm decline down to clearance for agriculture, or was it down to natural diseases of the trees? It's a point that Jim raised, and I would suspect that tree health was to a large extent down to the elm clearance, I suspect. The other point about clearance of trees is that it doesn't happen overnight. We're talking about quite large trees, and you can kill the trees by ring barking them, but you can spend a lot of time waiting for the tree to rot sufficiently for you to do any sensible agriculture. And if you go to Australia today, to the areas that were cleared of trees in the 1920s, using steam engines and diesel tractors and things, you will find piles of tree trunks in the corners of the fields. Now, they wouldn't have been able to do that in the Neolithic. So it's likely that agriculture really only develops on a wide scale in the washland areas in sometime in the Middle Bronze Age, but more particularly from the Iron Age. Right. Moving on to ritual and ceremony, which has been mentioned a couple of times, the washlands is notable for the so-called cursus monuments, but there are groups of monuments of varying kinds, particularly around Thornborough, that area, the Middle Ure, and on the Swale as well, in the middle reaches of the Swale. And those are very variable in terms of what they have. This is a map showing more or less where they run, and the obvious line is that they run up the A1 corridor. there. And you heard me mention that there was a lot of talk of east-west travel in earlier prehistory as opposed to north-south travel. Well, when you look at the monuments, these are on the Ure and the Swale there, running up. There are also traces of similar complexes moving north, so on the Tees and on the Weir, and way up there on the lower parts of the Tyne, and then to the south down as far as Ferry Bridge. I think it's, I can't read it from here. Ferry Bridge, and yeah, down there. Monument complexes, which a couple of years ago one was tempted to suggest that they do have some indication that they might imply a route across the Pennines, but there are two things that make one worry about that now, and one of them is that the Castle Dykes henge has been identified as an Iron Age site rather than a Bronze Age one, and the other one is that there might be that might have been wishful thinking to suggest that the Maiden Castle just outside Reeth might be Neolithic. Take those two out, and you're not left with much evidence for movement of people across the Pennines. You do have a confirmed henge at Yarnbury. Henges are earthwork bank structures with a ditch inside the bank, which tends to suggest a ceremonial function rather than a military function or defensive function. And henges are used for a multiplicity of purposes. Quite what those were is very hard to determine. Some of the Southern English ones are characterised by timber structures inside, big circular timbers structures. There isn't much evidence for activities inside the Swale Ure henges. They're called henges really by antiquarians, but the name seems to have stuck, not always very helpfully. Let's show you some of the monuments that exist in the monument complexes. And at Catterick we have a large flat stone cairn, which is almost certainly late Neolithic and early Bronze Age, so round about 28 to 1800, something like that. Also at Catterick there is a very large structure, concentric timber circles, concentric timber palisade circles, not henges, but a circle, dated again to the early Bronze Age, round about 1700 BC. Rock art doesn't usually occur anywhere in the washlands, but there is a large chunk of rock art from, again, the Swale Ure, from the Swale complex at Brompton-on-Swale. At Brompton-on-Swale, the monuments are focused around both sides of the River Swale. That rock art dates to, as far as we know, the late Neolithic, so round about 28, something like that, at a guess. Rock art is notoriously difficult to date. And there is also a very substantial mound in the centre of Catterick village, which looks for all the world like a burial mound. Again, it's very substantial. It's likely to be Neolithic rather than early Bronze Age. Right, and then here, the Thornborough henges. 1 henge, 2 henge, 3 henge, that one. Tree planted in the early 20th century. But there they are. They're very impressive from the air. From the ground is another story. And they have been christened the Stonehenge of the North, which I don't think is at all helpful to either archaeology or archaeologists or the general public. The number of times I've been asked what the Stonehenge of the North looks like, I say, it's a bank and ditch. And they look at me disbelievingly. And I say, you are recommended to go, if you want to see a monument in this area, go and visit the standing stones at Borough Bridge, rather than this muddy field with no interpretation. And when I visited it, some rather too eager cattle to chase you around. So Stonehenge it may be, or at least it may be contemporary with elements of Stonehenge, but calling it Stonehenge of the North is not something which helps anybody. So I think I'm trying to persuade Historic England that is a more sensible view. Right, this is the Hutton Moor henge, showing as a crop mark. You can't really see it from the air except in a really good year when the crops are ripened out and the weather conditions been right, and you can see the ditch of the henge. These henges are characterised by a ditch on each side. They're big, or at least they started off big. Big earthworks, a bank and a ditch, and by big I mean something like 5 metre high banks, 5 metre deep ditches for them. So very substantial, but it's a demonstration of the intensity of agriculture in the washlands in the period probably largely since the beginning of the 20th century, when we get tractor ploughing and machinery, basically. That is the time when these monuments mostly got more or less destroyed. Before that, horse ploughing would be slow, but you could bring a gang of labourers in to reduce the earthwork somewhat, and that did happen. Looking at the area around the Ure monuments, there are a range of them. This is a large barrow, potentially Neolithic, but these monument complexes attracted other monuments to them, and including early Bronze Age burial mounds. So it may not be Neolithic. More likely, some remained in use into the early Bronze Age. This is pottery from Sowerby, Thirsk, which is still part of that Middle Ure monument complex. Food vessels, early Bronze Age, particularly fine piece of potting. It really is. It would challenge any potter to make now. Right, there's a table there, but you don't need to spend a lot of time looking at it. But it does indicate what ranges of things there are in the monument complexes. So you can see, first of all, the complexes down here and the range of sites in them, and they're highly variable. So it's very difficult to say, oh, well, a monument complex like this, if it's got a henge, there's probably going to be some round barrows and there's going to be standing stones and things like that. You have to take them as the evidence suggests, and we know that not all the evidence does survive well. So the common feature is a henge, a large circular earthwork, but it may also include mounds, stone alignment, timber circles. So it's very variable. But the best site, if you really want to go and see a site out in the field, the best one is without doubt, the 3 surviving of 4 standing stones at Borough Bridge. Right, so to summarise ritual and ceremony, the monuments suggest that people gathered not just at the henges, having travelled along a north-south route or travelled in from East Yorkshire. East Yorkshire is where we know that there was a significant population existing, in contrast to the Pennines, for instance, and in contrast, perhaps, to the Vale of York as well. Vale of York is where the monuments are, but was it where the people lived? Perhaps not in the kind of quantity or density that the monuments suggest were needed, that needed a larger population. So it may be that people came to the henges and to the monument complexes to trade or to collect goods, items that they wanted. Some of those were stone axes that had been produced in Cumbria. But the idea that large numbers of people were travelling across to Cumbria to pick up the occasional axe is highly unlikely. So I think it's more likely that people are gathering where they can meet other people and trade or acquire items at the same time. And the number of people that might have been actually involved in bringing things to market, if you see it like that, might have been much smaller, and that would be reflected in the absence of monuments within the Pennines as a whole. Pennine routes may have been limited, travelled by traders rather than the broader populations from East Yorkshire. Thanks very much.
Thank you very much, Blaise. Absolutely fascinating. Obviously, we can't do justice to those sorts of timescales in literally an hour or so, but we've got time for a few questions before a coffee break. Anybody want to ask our distinguished guests a first question? Simon.
Far one in. Blaise, it's just fascinating to me when you show that north-south line of archaeological interest. Do you have any theories? Are there any sort of particular theories as to why there is so much emphasis on the Thornborough Henges, Burrow Bridge, Arrows complex within that line?
No, the only things I can suggest are kind of pretty well summarised. I think one thing you can say is that it needed a population to build them, and the short answer is that the only place there was a population is likely to have been a communication route. So people are focusing on the henge sites. And that exists over a period of a distance of something like 40 odd 50 miles, something like that, maybe more. But they're doing that for a long period of time, and I think it's sensible to think that the monuments themselves changed their character over the time that they were in use. If they're constructed round about, say, for sake of argument, 2,800 and earlier, 3,000, say, so even more, 3,000 BC through to maybe 1,800 BC, but they're still continuing to have uses even in the medieval period, because the henge at Thornborough has medieval pottery in it, and quite high status medieval pottery, kind of thing that it wasn't used for living in, but it was used for trading. So the uses of them will have changed over time. Why they exist just where they exist, well, I think it's a communication route, and people could get there readily, relatively.
Thanks, Blaise. Thank you.
Thank you. Can I just ask, were the Pennines a real barrier to movement?
Yes, they were.
Why would that have been?
Well, because they weren't a barrier if you knew your way around. And if you were used to travelling, they would have been a significant barrier if you had a family. You know, how did people, and that's why I put the picture of a train on. Getting around was an extremely slow business, and most people would not have wanted to get around beyond what was necessary to get a living, to find a mate, to find friends. So I think the reasons you would move, and also to answer religious needs or feelings, but in general, I think most people didn't want to move very far. They couldn't, because of as soon as you start farming, you're stuck,
tied to the land.
and particularly as soon as you start growing anything. And I've often thought that actually you can be an animal farmer and retain a semi-sedentary approach to life. As soon as you put crops in, you can't. But also, you don't want to farm in the Pennines in the middle of winter.
Quite. And presumably, if the individual population, the expansion wasn't actually that rapid, so that there wasn't the sort of the migratory incentive or requirement?
The population the population of Roman Britain is probably what it was in the Iron Age, or in the later Iron Age, say, the population, I think it's something like, I may be wrong on this one, but I think it's something like 4 million.
Right.
I mean, it's not nothing like
No.
what we see with the Industrial Revolution.
Yeah, quite. Fantastic. Any other questions? Mary?
A question for the geography speakers. What do the signatures, what do you think the signature of today's land use will look like, say, for a geographer looking back in 1,000 years' time? I mean, can you see the intensification of farming? Can you see the channeling of rivers and the change of land use? What would that show up like?
Do you want to do that, Dave?
Well, I think that's mostly for Jim, but one thing I could mention is that lowest terrace at Ripon, I didn't mention that at all, has got breeze blocks in it. So we are leaving. Have you heard the term Anthropocene? Yes. Well, we're leaving an Anthropocene signature, which will be vastly more complex than anything that went before.
That's right, that's right. And if we look at it from the environmental point of view, certainly since the Second World War or something, there's been a lot of manipulation, sort of in terms of drainage and growing exotic crops, different sorts of land use that aren't traditional. And I think you'd be able to see quite a sharp break between what had gone even right up to the start of the 20th century and what is happening now and in the future. And there'll be a wide range of different kinds of evidence and proxies that you could use, particularly exotic things that are coming in, but also the way in which the landscape's actually organised. Much bigger, more intensity, much bigger, and really quite a big difference to what's gone before. Even Blaise might agree, over thousands of years, and a big sort of sea change at the present time. And I don't know what the future's going to bring, but
Not looking forward to it.
no, probably not.
Any more questions? Yes, thank you.
There's loads of brilliant information there, and I'm just kind of wondering what sort of extent is that used to inform the management that goes on the reserves today, and how far back do you go with that?
Simon, do you have a comment to make on that?
Yeah, well, I will.
It's getting serious now.
I'm conscious it's time for a coffee break, so I won't dwell on it.
Well, you've got hang on a minute, you've got another 5 minutes. Not going to get away that easily. Go on.
Stephen, in answer to that one, it's been incredibly valuable to us, because I think in terms of landform, it's that recognition of how there were wetlands. I mean, particularly taking the Nostfield area that we focus on, we know that there was extensive wetlands around what is now Nostfield Quarry, and of course the river off to the south. So the Thornborough Henges were sitting on this plain between a huge swamp and the river corridor, which sort of starts to conjure up an image. But then with the work that Jim did with Mairead, looking at the pollen plant macrofossils and so on, we've then been able to learn a lot from that. So you can see that how it was a treed landscape, but then it sort of swamp and then through into agriculture. And we can then see some of the individual plants that were growing there. Now, as Jim says, and he knows so much more than I do, certain pollen, for instance poplar, just disappears very quickly and doesn't survive. So you are sort of trying to join up the dots. But then when you've got beetle remains, you know that some of those beetles survived in a particular landscape. Mollusks, same thing. So it's building a picture from the paleoenvironmental data that gives you a sense of what the landscape was like. And what's been so exciting is to then go and collect the seeds of some of the plants that are now really, really rare, reintroduce them, and they romp away. They want to grow here. So that's absolutely key point, and we really do learn a lot from it. And it gives, I think, integrity to to seeking to, you're not recreating the habitat, you're creating a habitat that reflects something of the character of the last landscape.
Well, let's take a coffee break, if we may. Come back just before 11:30 to start again for the second part. Thank you. See you all soon. Great. So on to the final session this morning. If I can get my glasses, I can actually read something. And our next speaker is Martin Hammond, who's going to give us a talk about the historic habitats of the lower Ure Valley, and then followed by Dr Arved Schwendel. Is Dr Schwendel here? Got you, right, excellent. Following on for 20 minutes after Martin. So Martin, over to you.
Thank you. So I'm going to talk about, I should probably say, some of the historic habitats of the lower Ure Valley. When I talk about landscape history, I often get sort of heckled by the forestry people who complain that I don't talk about woodland enough. It's because it's something that I haven't really researched. So I'm going to be talking about the historic habitats of the lower Ure Valley, but most of the research that's been done has been in a slightly wider context of what we've called the Swale and Ure washlands, based on this late glacial deposition of mineral sediments that you've heard about earlier. So really I'm talking about the lower Ure Valley, but also the lower Swale Valley. So if you think the lowland area between the moors to the east and the dales to the west. So one of the reasons for researching the history of the landscape during historic times is to understand the remnants of habitat that survive today. So the Lower Ure Conservation Trust was set up for quite a specific purpose in the mid to late 1990s to try and get a coherent approach to the restoration of mineral sites, of which there are many quarry sites in the washlands, but it's taken on, its role has kind of like expanded and broadened since then. But one thing the Trust has always tried to do is to look at the restoration and recreation of habitats firmly rooted in the local landscape. There is a tendency for people to use sort of rather generic solutions. We've always wanted to look at habitats as very, very specific, understand where they've come from and what their future might be. So this evidence base has a number of strands, and you've heard before me about the deep history of the local landscape. We've also done research on which species have been lost. So in this area, we've got a fantastic archive of botanical records that go back to the 1680s, actually. And that tells us a great deal about the fine grain of environmental change over the past 200 or 300 years. We've done surveys of the habitats that do remain, and they tend to be small, quite fragmented and quite scattered, but they are important because they're our library of genetic material that allows us to potentially restore and recreate habitats using local provenance material. But they're also our templates, if you like, for habitat restoration. And then the fourth strand is what I'm going to very quickly rush through 1,000 years of land use history, which is the habitats, or many of the habitats that we value most highly today, like species-rich grasslands and so on, are very much the product of how people have managed the landscape. And I'm going to be talking about the period really from round about the Norman conquest through to the parliamentary enclosure era, roughly 1750 to 1850, which brought about major changes in the landscape. So when you're researching landscape history, there's lots of different sources. Something people often don't realise is that the feudal system was incredibly bureaucratic. At the village level, there was quite robust systems of self-government, if you like, but there's lots of record keeping involved there. So, you know, we can look back and we can find out that in 1462, Mrs. So-and-so was keeping too many ponies on the common and got fined for it. Higher up the social hierarchy, the Crown was very, very interested in what you owned and where you owned for taxation and inheritance purposes. So there is a lot of documentation, and these are just some of the sources. One thing I will mention, because we're here at Fountains Abbey, monastic inventories are a very important source. On the slide there is an excerpt from a document called the Monasticon Iboricense, which somebody compiled in the 18th century based on all the pre-dissolution monastic records that were available. So this is a huge inventory of all the gifts and dedications to monasteries. These were very, very well documented because, you know, as people thought at the time, if you got to the pearly gates and knocked on the door, if your name wasn't in the book, St. Peter wasn't letting you in. So if you made a donation to a monastery, that had to be recorded for posterity. And so that, you know, throws up an enormous amount of information, because often people didn't actually own land, but they owned rights to do things. So it might be the right to graze a number of livestock on the common. It might be the right to take hay from a number of strips on the meadows and the ings. It might be the right to take a certain number of cartloads of turfs from the local mire as peat. So just I'll mention two particularly interesting sources. Although the ordinary people, the peasants, the small farmers, had effectively no representation in political life, at the village level, there were manorial courts that were effectively like, well, I say they were like parish councils. They were a lot more powerful and all-encompassing than parish councils, and they governed, amongst other things, They governed the use of shared resources, which included everything from the timber bridge over the stream to the gullies that ran through the village to the common lands that I'm going to talk about, and all the matters arising were recorded. All the minutes were recorded in what were known as manorial rolls, because they tended to be written on. They didn't have A4 notebooks. They had continuous parchment, and the clerk would write things down. And in the county archives in Northallerton, there are huge, I mean, enormous amounts of manorial roll material. Very, very little of it, unfortunately, has been transcribed and translated. So up to about the sort of mid-17th century, it tended to be written in Latin, but it tended to be written in Latin in this very elaborate script, but as it's very, very much a shorthand version, because the clerk had to sit there and write it all down contemporaneously. So it's very abbreviated, and every now and again you'll get these long Latin phrases and then Yorkshireisms thrown in. So there's an enormous amount. It is very, very colourful. It's, you know, amazing things about so-and-so got, you know, chastised by the court because they had let their scabby dog run down the street and things like that. So it was obviously a very strong sense of community, but people policed each other to quite a remarkable degree, and all this is written down. So that's a great source of information about land use. Oops. Another really fascinating document is the perambulation of the Liberty of Ripon from 1481. So before accurate maps became widely available, if you wanted to record an important boundary, and boundaries changed, the vegetation, the landscape changed, sometimes it changed quite dramatically, for instance, if the river altered course, you had to go out and periodically do a detailed written description of those boundaries. So it's often called a beating of the bounds, or a perambulation in this case. So because the Liberty of Ripon was an important boundary, it had all sorts of legal implications, it was periodically they would have to go out and rewrite the description of it. And this was a great big procession. You know, they had choristers, they had priests, they had church officials, they had clerks, they had witnesses and so on. And this goes from just downstream of Ripon right up to sort of like the top of Nidderdale and back. So it was a very long procession. It must have taken several days, but it's all written down. Again, it's written down in some tremendous detail. So they talk about things like there are marker stones, which are a very obvious thing. There are fords across the river, but they also talk about things like the grass bulks running through the open arable fields of the townships. They talk about where the meadows were, where the common pastures were, where the enclosed private fields were. They talk about walls and lanes. They talk about landmark trees. So they'll say kind of like the path then comes out by a large elder bush on the lane to so-and-so. So that gives us tremendous window into the late medieval landscape of the lower Ure Valley. So what did this landscape look like? Well, each township, each village, essentially had three main types of agricultural resource, and then it also had wetlands. So the three main types of agricultural land were largely managed under collective arrangements by the village, hence the manorial courts. All that had to be overseen. So you had a number of arable fields that were managed on rotation around the village. So if you know somewhere that's called, say, Westfield Lane, that was literally the lane that went to the western one of these arable fields. These names often persist in the landscape. You would also have the moor or common, or a number of moors or commons that were common grazing land, but they also yielded things like bracken, which was really important. Think of it as a pest plant now, but bracken was really, jealously guarded because it was a source of bedding, and it was also burnt to make a kind of fertilizer. Gorse. Gorse, again, something we often try and get rid of in terms of land management now, but it was absolutely essential for firing baking ovens and so on. So people would literally, where neighbouring townships shared common land, there are plenty of legal records of them turning up with their axes and their weapons and so on, because somebody was accusing the other neighbouring township of taking too many cartloads of gorse. And then there were the meadows, the ings, which were typically on the floodplain, and they would be divided into, like the arable fields, they would be divided into strips held by different tenants, by different householders. But after the hay crop was taken, they became part of the common grazing land, as did the arable stubbles. The wetlands, which were in many cases smaller areas, aren't so well documented, but usually they provided part of the common grazing land of the village, but they might also be cut over for peat or for sort of fibrous turf that would be burnt as a household fuel. And these wetlands were very often the kettle holes that were described earlier. They would just be small waterlogged features in the landscape, although I will mention later there were some larger examples. So some traces of the pre-enclosure landscape can still be seen on, just from place names really. I'm going to have to, I can't see that very well, but here we've got, for instance, Sowersykes Field would have been one of the arable fields. Ellenthorpe Ings there. This is just at the junction between the Ure and the Swale downstream of Boroughbridge. Ellenthorpe Ings, that was hay meadows. That was where the Battle of Myton took place. We know it was hay meadow then because one of the tactics of the Scottish Army was to set fire to haystacks as a smoke screen. We've got Aldborough Moor there, which was part of the common grazing land of Aldborough Township. So we can still find traces of those landscapes that really persisted for about 1,000 years. So we know this system of land use was in place during the medieval period. It wasn't just an invention of the post-conquest landscape. So meadows. Meadows are grasslands, permanent grasslands, that are reserved for the production of hay. So they're not grazed between about now and typically the middle of July, when the hay would have been harvested and taken away. It's difficult to appreciate now, but hay meadows were absolutely central to the medieval economy, and they were very, very valuable, and they were worth, in this area on average, hay meadows were worth 4 times as much as arable land per acre. Hay was essentially, it was like diesel is now. All your beasts of burden, all your transport animals, all your overwintered breeding stock needed hay, and they needed large quantities. If you can imagine how much hay a plough ox needs to keep it over the winter when the grass isn't growing outside, you're talking about large quantities of hay. The other thing to bear in mind with hay is when you harvest it, it is a crop, when you harvest it, you're removing a lot of nutrients from the soil on that site. So if you want to keep producing hay year after year after year without depleting your soil, you need to grow it somewhere where the fertility is naturally self-maintaining. And where's that? It's on river floodplains predominantly, because the input of silt replenishes the nutrients that have been taken out with the crop. So very often hay meadows were, this isn't exclusively, but very often hay meadows were on river or stream floodplains. And they could be along relatively small streams, as long as it was somewhere where you got at least occasional flooding and silt deposition. And these would typically, as I mentioned, be divided into a number of strips allocated to different householders, and then they would be grazed after the hay had been removed in July. They're sometimes referred to as Lammas meadows after Lammas Day, which is the 1st of August, which is when they would be broken or thrown open to common right grazing. This is some research that's been done by a heritage consultancy called Fyodor, and they've recently been developing some work that I'd done based on documentary sources. They've been looking at tithe records and field shapes to try and reconstruct where floodplain hay meadows were historically. You can see that's the Ure Valley on the left, and you've got the Swale on the right there. So you can see that this was a widespread and important land use. And we've lost entire sort of floodplain landscapes because this has gone. We know that within the lower Ure and Swale valleys, there were at least 100 of these floodplain ings. And prior to the enclosures, there was probably more species-rich hay meadow in this little study area than there is in the entire UK now. And one of the things the perambulation mentions, because they're going backwards and forwards across the river, they're often crossing through these meadows, so you get named ings there. These meadows would have resembled, if any of you know, the meadows of the Ouse and Derwent ings, where there are some relatively intact examples. That's a picture of Clifton ings on the outskirts of York. The lower Derwent Valley along the North Yorkshire, East Yorkshire border is the largest area largest remaining area of these meadows in Britain. But as far as we know, in the lower Ure Valley, there are none that survive in their original form. These must have been wonderfully wildlife-rich habitats at one time, as well as being rich in wildflowers. This is an extract from a poem by a Civil War era poet, Andrew Marvell. He's actually talking about the ings at the junction of the Ouse and the Wharfe, so a little bit further downstream, but not far outside our area. This is a very lengthy, very metaphorical, allegorical poem, but he talks about the sorrow and anguish of one of the scythesmen after he cut a corncrake on its nest, and all the kind of like symbolism that went with that. So these meadows would have been full of corncrakes and curlews and all sorts of other birds. So the moors were large areas of common grazing land. Some townships had several. Sometimes they shared them with other villages. normally you couldn't just let your cattle on there. Grazing rights were stinted, which means they were rationed. So as part of your tenancy, you had the right to a certain number of livestock, and it would be a little bit like the system of livestock units today. So it'd be like 1 horse equals 1 cow equals 5 sheep, or whatever. There were local rules for that. This was very strictly monitored and overseen. So you were soon found out if you had more than your ration of beasts on the common. You weren't allowed to put diseased animals. You weren't allowed to put stallions on there if there were mares and so on. And sometimes villages would have very specific areas of common for specific types of livestock. An oxmoor or an ox close would be for the plough oxen of that village, the horse pasture of the bull close, and so on. I mentioned before, commons provided other resources like gorse, sometimes withies for willows for basket weaving, and bracken. Sometimes there would be a system of shepherding. So Hutton Moor, which is a very large common, each village had its own shepherd. And in terms of the habitats these moors would have provided, that would have varied according to soil type. So for instance, Hutton Moor, which is kind of like it's on the watershed between the Ure and Swale catchments, it's an area immediately west of the A1 that served several townships. We know from old botanical records that this was predominantly sandy, heathery land. It would have been heathland on mainly acidic soils. Thornton Watless Moor, by contrast, is on the Magnesian limestone. It's predominantly arable land since it's been enclosed. But this here is the verge on Moor Lane, which is the last little remnant of limestone grassland there with the clustered bellflower and so on, still hanging on as a mark of what the much wider landscape looked like 250 years before. During the enclosure period, it came to a time where these age-old systems of managing the land were becoming increasingly redundant. It was much more changes in technology and the makeup of the population meant it was becoming much more efficient to have your own land and manage it as your own farm. So there was a big push to break up these commons into privately owned fields. So we've identified about 180 of these moors in the lower Ure and Swale valleys, some of which were very large. So this was a major land use during medieval and early modern times. And even by the kind of like late 18th century, there was about 12,000 acres that were left to be enclosed. Mires were these wetland areas, these waterlogged hollows in the landscape. And because they were essentially dimples in the landscape, until you had machines to dig big drains or to pump the water out of them, they tended to be limited in what you could do with them. And there was a big push to drain the Vale of Mowbray cars, as they were called, usually called cars or mires. There was a big push towards the end of the 18th century to drain these. But prior to that, most townships had one or more of these cars. They would sometimes be used as a source of turf. So in the monasticon, in the inventory of gifts to the monasteries, we've identified at least 10 of these turbaries where peat was cut. Almost all of them were gifted to fountains. And in the wider Swale and Ure valleys, we've identified about 150 wetland sites. Some of these were small, as I mentioned, but there were larger areas such as Snake Mires, which is admittedly just into the Swale catchment, but that was a wetland of perhaps 5 square kilometres that was still mapped in the late 18th century. It was drained soon after then, but it would have been one of Yorkshire's great wetlands with all the wildlife that went with that. One kind of like solitary indication of that is the Leach House at Bedale, if you know that. That was literally sort of leeches are us. You know, the apothecaries would go to the leech warehouse. It was literally a leech warehouse. So there must have been very large wetland areas which produced enough medicinal leeches to make that worthwhile. Wetland habitats, as with the grasslands, would have varied according to the water and soil chemistry. We know from botanical records there were a surprising number of wetlands with seeping calcium-rich water. So plants like bird's eye primrose and black bogrush, which are now only at sites, one or two sites, right on the edges of the washland, were much, much more widespread right across the Central Vale, which is interesting. But also interesting, given that this is an area with predominantly calcareous, lime-rich geology, there were acidic mires at several sites, including Tanfield Hall Car and on Hutton Moor and at Martinley Moor. I think Jim showed a slide of the succession on these sites. So over time, they fill with what was originally a small lake would fill with sediment. It would become reed swamp, fen, might develop into a kind of wet woodland. Then eventually peat would accumulate above the level of the groundwater, and this would form an acidic environment over time and become dominated by sphagnum mosses. So several of these sites existed in the lower Ure Valley, and that's a habitat that's just gone completely. I will mention meres. These are natural shallow lakes, so these occupied the larger depressions in the landscape. I talked a little bit about snake mires, so this is on Jeffrey's map of Yorkshire from 1782, is it? I got the date right there? Yeah. 1772, yeah, sorry. So that was a large wetland. There are another cluster of these sites in the headwaters of the River Wiske. This is one that this winter just got flooded again. So the basin's still there. It's definitely a basin. The farmer does try and grow crops, but not very successfully in it. But this winter, it really reverted to what it must have looked like for many centuries. And there it is with a flock of hooper swans sat very contentedly on it. Another feature I'll mention finally is meanders. So we've already heard about river migration. We're going to hear a bit more about river migration. It's a very, very strong defining feature of the lower Ure Valley. And it's been known about for a long time. So this is an extract from it's a transcript from, again, the Ripon perambulation. It was written in Latin. It's had to be translated. But there, it talks about the old courses. They were very familiar with the old courses of the River Ure and the way that the Ure had changed its path across the landscape. And in many cases, the original boundary of the Liberty of Ripon, which was a pre-Norman conquest boundary, followed courses that the river had long since abandoned. And you can sometimes see this on maps. If you look in river valleys and you sometimes look at parish boundaries, you think, how on earth does that make any sense? You see these really bizarre, wiggly boundaries, and that's because the river's changed course, and it originally followed the local beck or river, and it makes sense in that context. So there were, of course, other types of habitat. Parkland was quite an important feature, Ripon Parks being a major area. And there were, although there was no extensive forest-type woodland from the late Iron Age onwards, there were scattered woods across the landscape, some of which have now disappeared, and with the Hackfall Gorge probably arguably being the most important remnant of ancient woodland in the lower Ure Valley. But I will stop there.
It's truly fascinating to see. Whenever I hear that sort of talk or read this material, it tends to make me feel as though I want to actually go back and live at that time. Again, as long as you've got good health service, etc. But it does show how, if you look now at what we have in our landscape, most of it is utterly wrecked, I'm sorry to say, by a whole industrialisation of the landscape. And I was going to come on to that later at the end with a few questions around that, because I think it's particularly exciting and interesting and in depressing in equal measure. But let's move on. Our next speaker is Dr Arved Schwendel, and Arved's going to talk to us about the Ripon Loop, the interaction between the dolines and the river dynamics. And I've probably pronounced dolines wrongly.
Dolines correctly.
Yeah, okay.
Thank you.
Thank you.
Yes, good afternoon. I think it is afternoon now, yeah. So, okay, I'd like to, perhaps for some of you introduce, but some of you know it already, Ripon Loop, which is just north of Ripon, and the interaction between dolines, which are commonly called sinkholes, but doline is the correct international term, which I'm trying to use, and river dynamics on the example of Ripon Loop. So, I don't need to tell you where the river Ure is, but the site we're looking at is just north of Ripon here, and importantly sitting on the Permian limestone and gypsum strata. Perhaps one figure to remember is the mean discharge of the river Ure at Ripon is more than 20 cubic meters per second, so quite a substantial river if we talk about comparisons with other places in the UK. Then, sorry, the next thing I'd like to show is the dynamics on that meander bend. So we see here the historical Ordnance Survey maps that reveal the river course, and you can see it's been highly dynamic over the last, say, 170 years, with numerous smaller cut-offs happening here, avulsions in the lower part, forming this big so-called compound meander bend. Compound because it contains many smaller bends, so it's quite a substantial long bend, or has been until 2019. And in 2019, this was cut off here across the neck of the bend. And that's something I investigate with a colleague, Tony Cooper from the British Geological Survey, who is an expert on dolines and subsidence in the Ripon area, or gypsum in general. So speaking of gypsum, it's worth looking at geology. And the buried valley that has been mentioned earlier today is basically the underlying the river Ure. I think they've got So the course of the buried valley that was mentioned earlier is pretty much underneath the river Ure in this place. And on the edges we've got Permian and early Triassic formations. So we have these limestones of the Brotherton and Caterpie Formation. And then in between, we've got marley, gypsum, and on the next slide, we can see how that influences the landscape. So the map on the right is from Cooper 1989, showing a lot of dolines in the Ripon area, including along Ripon Loop, which is up here. And he has drawn a cross-section across the valley here, just north of Ripon, which shows how the geology influences the surface. So we've got groundwater flowing from the Yorkshire Dales through this limestone, which is a good aquifer. And then it has artesian pressure, and it moves into the gypsum here, creates cavities, and eventually discharges into this buried valley on which the river Ure contemporarily sits up here. And while doing so, while flowing through gypsum, it dissolves gypsum, creates great cavities. Gypsum is much more soluble than limestone, and dissolves much faster, and as such creating these cavities which create collapse dolines on the surface if the surface layers of rock or loose sediment are not competent enough to hold the weight, and then they collapse and create these dolines that you can see all along this buried valley here and in the bedrock nearby. So it is quite an important and quite a rare feature that we see here. These so-called cover collapse dolines, because the cover material is unconsolidated, is these sands and gravels that fill these old buried valley. In the field they look like this. This is 2019 on Ripon Loop, and you can see they're quite distinct, have very steep side walls, and most of them were water filled. And if you look at the LiDAR image, you can see in yellow, hopefully you can see that, the mapped dolines across the area here. We also notice there's other holes in the landscape here. These are mainly military excavations, because Ripon Loop has been used as a military training site for, I think, more than 100 years at least. And so it's sometimes tricky to distinguish these dolines from military excavations, but Tony has developed a method that looking at the surrounding area, looking at the rim or the edge of the depressions, and also their size, and so was very confident to distinguish them. So we used historic maps, we used multispectral scans, we used aerial photos, and we used LiDAR scans in order to create about 16 data sets spanning back to 170 years to identify the dynamics of these dolines over time. The differences between the dolines mapped in brown and then these military excavations in purple. And a little bit more zoomed in, you can see the different groups of dolines we found here. Some of them were quite distinct, other ones were more dynamic along here. And in the next slide, I'm going to outline that basically found two populations of dolines. First of all, these marked here in red, these were long-lived, constant size, permanently active, but at a very low level. So they need to be active because otherwise on the floodplain they will be filled in with material that's been transported there by overbank flooding, so fine materials that provide then a very great archaeological record. In this case, they are still visible after more than 100 years being mapped. That means they need to be constantly active, but they retain their size and they're not really moving around. In contrast, the yellow population, B, is highly active, and you can see they're actually changing in size quite a lot. They become elongated, they coalesce, so quite interesting how they move around, and they were the focus of our attention because as a river scientist, you like dynamics, you like things that where something's happening. So we looked at this yellow group, this second group, in particular their area over time, and we can see that looking at different groups of sinkholes, G2 up to G9, we can see that there was kind of a relatively constant size, and then in the last 10 years, they all seem to be growing quite dramatically. And if you look at the cumulative doline area of all these six groups, you can see that basically increasing quite substantially between 1986 and 2001, then a little bit further increase to 2009. 2015 saw a little bit of decrease. That's partly due to the data source we used in 2015, but also shows perhaps infill of some of the dolines by the increased fluvial dynamics that I'm explaining a little later on. And then quite a substantial increase again to 2019. So it seems very clear that this second group is quite working dynamically. Now I'd like to move to the meander cutoff that happened here in 2019. So perhaps more principle what was this meander cutoff. I had a question on the field trip the other day, so I think it's worth explaining. There's two types of meander cutoffs that we distinguish. One of them are so-called neck cutoffs. It's basically where two bends are migrating across the floodplain. Eventually they get so close, well, best here, you get so close that basically they overlap, and when they overlap, they create a new channel that, and then this old bend becomes eventually abandoned and might terrestrialize at some point. The second type we recognize are shoot cutoffs. Here, the two limbs of the meander don't get very close to each other, but for other reasons, a channel can form across the neck of the meander bend. And there's various mechanisms and processes that are responsible for that. Perhaps most important, scour from overbank flow, but also seepage through gravels has been identified as an initiator for these kind of cutoffs. And which path these cutoffs take is normally they're very straight, as you can see here, or in this example here. Or again here, they're usually slightly bent, but most of them very direct. So that's influenced usually by vegetation structure or topography, for example, occupying old channels or finding areas with low vegetation density, which provides less roughness, and therefore water can flow quicker and scour quicker. So if we look at Ripon Loop, its hydrograph, we notice very frequent flooding, normally at a level, I think, about 1 meter, a bit less than 1 meter at the gauge at Ripon Bridge. So that's roughly here. Overbank flow happens there. So you can see over this period, overbank flow happened relatively frequently, on average every 13.7 days for about 15 hours. So quite highly dynamic and quite a lot exposure to flooding. In the last 7 years before the cutoff, we saw an increase in floodplain scour along this neck of the Ripon Loop. You can see here the image showing basically small channels scoured into the surface, then leading to the first doline, which is just about here. And in an aerial view, you can see again here this chain of dolines, and here perhaps you can notice that the incision from overbank flows kind of radially moving towards that first top doline, and then the movement of the overbank scour was basically across this chain of dolines, ending eventually here and discharging into the River Ure again on the lower limb of the meander. So in 2019, September 2019, this was imminent, and we can see we are at this point here just before the first autumn floods are happening, or just the first autumn flood actually is happening. David Powell thankfully took a video. I'm not sure if that's, how can I play this video? It's not playing. Okay, that shows basically the first cutoff channel in 2019, and you can see it's not very wide. It's about 3 meters wide. It's really just occupying this chain of sinkholes, of dolines going across them, and that was kind of the start. Then in October 2019, so after the first set of floods in autumn, we can see even at low water, you can see it's still going along here, following the chain of dolines. Small channel is actually outside the main flow. The main flow is coming across here and then going into the meander still. So it's kind of backwater flooding, but it's maintaining a permanent channel even at less than overbank conditions. Oh, it's working actually. So you can see, a short flight across here. And you see also how it discharges further down here, becoming into a more permanent channel down here. So then October, December, there's not much record, but there was quite some floods, particularly in early December. In January, it looked like this. These are photos from the Environment Agency showing a quite straight and quite substantial permanent channel now, which carries most of the flow from the River Ure across this chute channel. At this point, the cutoff had actually occurred, so one can argue late December or early January. And I was desperate to survey at this point, but I couldn't. So just looking at the effects of the overland flow, if we normally you would imagine that this scour of overland flow has some influence on the sinkhole area or the doline area. However, if you look at the overbank flow in the previous 2 years and the changes in doline area, we find no clear relationship here. There is no relationship. So there is obviously some influence, and we can see, for example, sedimentation in the lower parts of the dolines, that here and here, of course, river gravels that has been washed in from overbank flows. And we can see at the upstream end of the dolines also head cut scour, so basically water's flowing in across the floodplain into the holes and eroding this edge of the dolines. So that's clearly fluvial action happening here. But in the larger picture, the size of the dolines hasn't really changed depending on overland flows, not as far as we can tell at least. So I mentioned I was desperate to survey at this point. However, February was exceptionally wet, and so I only managed in early March to survey for the first time. So there's the details. Don't think that's most relevant for you, but I used a UAV, applied structure from motion processing of the photos that I've taken. That's create a digital elevation model, and I then used an older LiDAR image from 2015, modified it to account for any changes until 2019, and compared it to the data set in 2019. So the result is something you can see here. On the left-hand side, you can see the DEM that, and superimposed the areas of dolines. And you can clearly see the cut-in channel here, wider at the top. You can see this bar situated here, and then the main channel rather narrow, and then here joining again the old channel of the River Ure. The other old channel of the River Ure is up here. So you can clearly see that incised area, and you can also see that these dolines are actually not center of the flow path anymore, at least not everywhere. So this first, the top one, is yet now occupied by a bar, this one as well, while these ones are kind of part of the channel. This one is filled in as well. And if we then calculate the difference, if we overlay these two DEMs and calculate the difference between them, we can see areas of scour and deposition. So scour is in red, deposition is in green. And you can see that, interestingly, some of the dolines have actually been filled in quite dramatically. I think that's, I think it might be just a light in here, but there's a bit blue in here as well. So most of these upper dolines have actually been filled. It's just not very visible here, while others are kind of in the main channel, so they have maintained their size, but they have not been eroded any further. In total, about 20,000, more than 20,000 cubic meters of gravel and sand have been exported from that area and distributed across the lower reach. You can see that in the pictures I'm showing later. Most of the dolines have been filled, and there's no apparent activity that kind of interferes with this fill. There's no evacuation of the material that has been filled into these dolines, at least not as far as we can see to this point. So since then I've taken, I think, another 15 photogrammetry-based DTMs, and you can see some of them as aerial photos on the right-hand side here. Again, superimposed the dolines. And what we can see from this is that the fluvial dynamics, at least in the first 2 years, are dominant. So the position of the dolines doesn't really seem to make a huge difference. There's no indication of subsidence that as far as we can see. The fluvial dynamics seem to be very much dominant at this point. However, in 2021, in spring 2021, summer 2021, sorry, I found some kind of little water seeping through the gravels here. This could be water coming, groundwater upwelling through the dolines, and therefore could be an indication of activity. Or it could be river water just percolating through the gravels. I couldn't test at that point the sulfate content, so I can't really tell where the water is coming from. But it's worth noting. And so the key question for me was, how do these subsidence dynamics and the river dynamics interact? And it seems to be very clear that these dolines have created stepping stones for this incision to occur. We can see that the path is clearly determined, of the initial cutoff channel is clearly determined by the location of the dolines. We also see that this head cut incision that happened at every doline is quite important to facilitate the incision of such a channel. Normally this head cut only occurs at the lowest point where the overbank flows drop back into the old channel. Now we've got several stepping stones where this can occur, and such the incision of this chute channel has been accelerated quite considerably thanks to the dolines. So we can say that they determine the path and they accelerate the process. On the other hand, the overbank flows also change the dolines. We've seen that there's headward incision on the upstream side, the position of bedload on the lower side, and but we cannot explain the difference, the dynamics we've seen in doline area by this. So there have been inception of new dolines, for example, G5. Other dolines have been coalesced, have grown. Other dolines completely off the path of the overland flow and have grown as well. And as such, there is an activity of dolines that cannot be explained by fluvial activity. So a theory is that perhaps there is increased subsidence activity in that we observe in the 8 years prior to the cutoff, could be explained by overland flows or subsurface flows through the gravels that interact with these dolines. I need to say that the river water is usually quite unsaturated in gypsum, so it potentially, if the groundwater conditions are right, it might be traveling down through the gravels and might, as aggressive water, increase subsidence. How this precisely works, I'm not exactly sure, but if it works, it could be a positive feedback between the overbank flows on subsidence, which then in turn increase the incision of a chute channel, so it could be a positive interaction between both, basically widening, increasing the size of sinkholes, and at the same time creating a chute channel that quite substantially affects the speed of this chute cutoff. So the open questions remains, how does this precisely work? I'm working on this. So which are the mechanisms and drivers for such subsidence activity? How does the aggressive river water actually affect the dolines? How does it can it actually get all the way down into the gypsum? Or is the artesian pressure of the groundwater strong enough to keep the river water out? So that's subject to ongoing research. Or perhaps these 8 years of increased subsidence activity, maybe it's not related at all to river water, maybe it's simply a signature of a wetter climate, and perhaps is simply dominated by higher rainfalls in the Pennines, where the water is eventually coming from. So that needs to be considered as well. And secondly, I'm interested in the fate of the dolines in the chute channel. We noticed in the first 2 years it was all dominated by fluvial processes, but we're now, 2024, so we're about 4 years after now, so I have some more data sets. I still haven't analyzed them yet, but this is work in progress. Finally, I just want to come to the consequence this has for Ripon Loop as a nature reserve. So we can see it here in its previous state before cutoff. You can see the dolines here. And if we click through March 2020 after the cutoff, we got the establishment of the chute channel. We've got a huge mid-channel bar. We've got former mid-channel bars which became lateral bars, or pretty much lateral bars. And then we've got still this very narrow chute channel down here. Then in June 2020, we can see the chute channel has straightened quite dramatically. It's very steep, very strong stream power, incising quite substantially. There's also quite a bit of incision along here. We could see how the gravels were exported through here. And then March 21, after a very wet winter and flooding winter, we can see there's substantial bank erosion, widening of the chute channel, also a slight bend forming in here. And this has continued since then. So by now we roughly have a channel that edges roughly around here. And also this bend at the south part of the chute cutoff has developed quite dramatically. So there's I think about 25, 30 meters of bank erosion here, and this bend is developing further. And more recently, it's actually rotated to erode more into this area, more into this direction rather than into this direction. So it's quite dynamic, especially after this, again, relatively wet winter. So for me, the kind of key points of interest from this early research is that the Ripon Loop is really a reference site for natural river development. And that's important for river restoration. It's important as a reference site because for rivers in this size, it's very rare to be allowed to create such river dynamics without being in some way harnessed by people. So this is a very important site as a reference, and perhaps this should be considered in the designation of the SSSI, that we've got such an important type site here. Secondly, for a reserve point of view, these changes in the geomorphology have quite increased the terrestrial and aquatic habitats. So terrestrial habitats, semi-terrestrial habitats, for example, the important riparian woodland here. We heard about meadows today, but the natural environment for rivers is riparian woodlands, and there are some exemplary examples around here, which again is for a reference status quite important. Of course, it created management issues in terms of access for the Yorkshire Wildlife Trust, which kind of makes management, or grassland management in particular, very difficult along here. But it's also an important site along the whole River Ure corridor with all the reserves along its way. And as such, again, I wonder if this could be perhaps considered for a redesignation of the SSSI, creating a coherent management scheme along the lower Ure Valley.
Can you wrap up?
Yes, I can. I think I am almost there. Yeah, thanks for your attention. And
fascinating, I think, to see the timescales involved, the dynamics involved, and the overlay of people into that landscape, and how that population has expanded so dramatically in recent years. And I'm reminded of a book actually called Collapse it's got a depressing title, I know, but by Jared Diamond, and he coins two phrases which come to mind. One is creeping normalcy. So it's basically how slowly the landscape changes over time, so that the landscape within which we live now is the landscape that we want to protect. And yet, when you go back thousands of years, what would it have looked like? And landscape amnesia is the second term he uses, which is we just forget in our own lifetimes what things were like. Even 50 or 70 or 80 years ago, we rely on our more elderly relatives to tell us what things were like. And I picked up, Martin mentioned the point about the quail being strimmed out. Well, it wouldn't have been a strimmer in those days, would it? Have been scythed out by the farmer at the time, and how things have changed so dramatically, and not by any stretch of the imagination for the good. Let's go for questions. I think we've had a fantastic morning. Any questions for for Martin and to Arved for this second session? Simon.
Hop up quickly for that, because I'm pulling one or two threads together, actually, if I may. I just find that so fascinating, and as we've got a few people here from